Hello and welcome back to Knife Making Tuesday. My name is John. Welcome to the shop. We are here to talk about the Fjell. This is our 3-inch blade, integral button lock sexiness. Okay, today is technically Wednesday. It's 12:06 a.m. Wednesday, October 23rd, 2024. It has been many months since we put up a video. We were at Blade Show in June. We sold 6 Fjells, and they're amazing. And then on top of the 6, I have one, Eric has one, and kind of the shop has one. So we've made 9. The first round, the first 9, and probably a bit more than that, we're going to call AP for Artist's Proof. So we got AP01, AP02. And we're going to cut that off at either 18 or maybe a little bit more depending. The goal with that is to establish a happiness with this product. A level of, how do you say, good enoughness. And be able to fine tune and streamline and get this thing to the level that I want it to be. I designed this knife in 2012. That is 12 years ago, my friends. That's too long. So I've been picking away at it for years and years, and here we are. Let me catch you guys up a little bit, and we'll see if we have any time. It's midnight. I want to go home. I want to go to bed. See if we have any time to get some actual work done. The Kern kind of derailed me a little bit for 2 hours, 2+. So, okay. This knife is really cool. I've been carrying it. I've been very much enjoying it. Eric's been carrying his. Angela's been carrying the shop one for quite a while. Most of the guys have carried it as well. Fun fact, the only component that shares across this knife to our other knives is this pivot screw. We make that, but that is the only part that is the same as on the other knives. Everything else of this is custom made for this part, for this knife. All new, like quite a bit different than what we've been doing before, so it's really cool. This blade is not finished yet. It's right off the machine, so we still have that tab right there. This little, I call it a booger, or a nose dribble, or I don't really have a name for it actually. I first learned about that from Halpern Titanium. They put up a picture on Instagram like 7 years ago. And I asked them what it was for, and that is to protect the tip during tumbling, because this blade will get polished, finished, go in the tumbler for 2+ hours, and any sharp corner, like a point, is going to get rounded. So we've been doing this on our Norseman blades, or rasp blades, for years, and it's great. And then that little nose dribble will get sharpened away, and it'll be gone, and then it'll look like this guy. Believe it or not, this is a Thor pattern Damasteel. It does not look like Thor pattern. Thor pattern usually looks a lot different than this. But it's like the end of a really wide bar, so it kind of looks all stripy. It's really cool. Okay, I'm gonna take this knife apart because I want to show you guys how it comes apart. And I'm gonna swap it for my Damasteel blade. Okay, I have multiple stop pins here in my setup zone. So all you need is a T9 to take this apart, just like all of our knives. This knife has 2 stop pins. Focus. This knife has 2 stop pins, just like all of our knives, except these are completely different. These guys thread in from the outside. This is an integral handle. There's one piece here. You can't put junk from the inside, like between 2 halves of a handle like we normally do. This is carved out of one solid piece of titanium, like so. Isn't that wild? I love it. Okay, taking this apart. So first step is to remove, I call it the big stop pin. That's your lockup stop pin. These guys are made of 17.4 pH, hardened, very fine thread. So that comes out. This allows the blade to open more than it should. This is important. Watch the button here. As the blade opens as it should, whoops, I got ahead of myself, it'll lock up, but in this scenario, it allows it to pop up more than it should. It allows the blade, or the button, to pop up, and now I can remove the button. And it's on the ground. I can also drop out the spring. This little tiny guy, don't lose it. Found it, found my button. Okay, now there's no button, no spring. People are definitely going to forget about the spring, and you will chop the spring. I can feel that spring tension right there. It'll get stuck. So we're going to include an extra spring with every knife, and we'll see how it goes. So now the blade can go. There's no locking mechanism anymore. And now I can remove the pivot. Pivot screw comes out. Okay, now the pivot can fall out. And now here, watch, the bearings will fall out. Boom, boom. We have recessed the inside of the handle for the bearing pockets. It is pretty slick, very tricky to do, very awesome. I do not like bearing pockets in the blade. I think it thins out the blade, I think it makes the blade weaker, and I really like rolling bearings on a lapped outside surface anyway. So we put the bearings in the handle. And on an integral, that is tricky. In previous Knife Making Tuesdays, I explained how we did that on this handle. What am I showing now? Okay. Basically, install is reverse of removal. Put the one bearing in. It's tricky to get the bearings in. Like, think about this. They just want to fall out. So what I do is I stand them up on end and I slide the other one in, and I kind of balance one in against gravity, and I take my little pokey tool and I get it through the pivot, and from here I can kind of guide both of them into place until they're kind of like resting there on a relatively level surface, and then I can put my blade in there, boom, done. Now I can put my pivot back together. Over the past few months since Blade Show, I haven't been able to dedicate a lot of time to this project, but I've dedicated a lot of mental time and quite a bit of both shop time and late at night, at home, and weekends, programming, tweaking, changing, fine-tuning, improving. As I'm carrying this first prototype, I'm realizing what I like, what I don't like, and what I want to change. So I've been spending the past few months kind of diving into that, and especially the past few weeks, more and more and more. It's getting really exciting. It's getting very, very close to actual production, to closing out the APs, making the last few, and then going into actual production, starting the serials over at 1 again. Eric and I always get 1 and 2. Oh darn, I get another knife. And actually start selling these like very, 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 very soon, like weeks or less than weeks. Unfortunately, I have not been filming any of these changes because I just didn't want to. Sorry. It's so much easier just to work than it is to film and work at the same time. It is what it is. Anyway, here we are. Let me catch you up. Where I'm at right now, we have a handle which is pretty much dialed. I've gone through, I think, 10 revisions of handles. I've got different ones. I've become the biggest fan in the world of rev numbering pretty much every component. The clip has a rev number, the handle has a rev number, the blade says 1.6, V1.6. And not only that, I've got a Google Sheets document, like an Excel spreadsheet, tracking every rev change and what I changed in Fusion, what was the results, what happened in real life. And that has been insanely helpful. So now I have a pile of garbage on my desk, and I can know, oh, that's V1.5, that's V1.6, that's V1.1. I can put that in the drawer. I'm never going to look at it again. It's been awesome. It's been fantastic. Helps me declutter my mind as to what all of the revisions are, put it in the sheet, track it, make my changes, and then I can go back later and I can see what I did and what happened, and it's been awesome. So the handle is pretty much dialed. I think I haven't made a handle in a few months, but I think it's just good to go. Still got to establish tool life on the Kern to make sure I can make like 10 in a row without busting tools. That's good. The clip is pretty amazing. It is a clip-in design that slips handle. So these little ears there bend a little bit and slip into this T-slot. It's got to be aligned just right and click. Kind of freaking sweet. What I don't like about it is this. There is a bit of a wiggle. When you have two, pardon, don't be teenagers right now, but when you have two sliding slots that go like this, there has to be a clearance for them to go together, and that clearance can, create movement, especially when you have two things and there's a gap and there's rotational, and you have call this almost 2 inches, 1.5 inches to like a 1/4 inch. So your leverage is insane. So if it's on my list to measure the actual movement, like put an indicator here and measure it, but I'm guessing it's like 20 thou. So that 20 thou equates to like 2 thou or less of wiggle. So I don't know. I'm trying to get these sliding tolerances to literally 2/10 tolerances, but it's still wiggling, and I don't, it bugs me. Eric says it's fine. I say it bugs me. Maybe it's fine for the first 100. I don't know. I don't know yet. If I can't fix it, or if I can't figure it out, I might just send it, and it's fine. I want to stick with this attachment style. I don't want to switch it up. I want to standardize. I want it to be good. I want it to work. I've thought about putting a little set screw in there that can pry the ears apart. That might be something. So I don't know. That's where I'm at with the clip. But programmatically, it's really cool that I can just remove this like that. I don't know if I actually want customers doing that, because they're gonna wear it out. They're gonna scratch it, they're gonna dent it, they're gonna bend the ears, they're gonna wear it out. It's gonna get worse and worse and worse. In retrospect, it's cool, but it's got its downsides. I don't know. It is pretty cool though. And this thing is fully 3D machined on the Williman from round bar, and it's awesome. So I'll dedicate a future video to this because it's really cool. Blades, I just made, they've got to be around here somewhere. Last night, 2 nights ago, I made 8 soft blades. So before heat treat, the guy surface ground them, I machined them, I engraved the serial numbers on them. They went through heat treat yesterday. Sky heat treated them, and now they're in Jeff surface ground them after heat treat, and then they're going to go to lapping, and then I think by tomorrow I should have them in my hands. So that's good. And I've been making kind of 1x1 testers. The problem with a blade is you got to get a blank, you got to surface grind the blank, you got to machine the blank, and you got to go through heat treat, and it's like days or even sometimes weeks before I physically get the knife, the blade back to me, even if it's all in our shop, because there's so many processes involved. So testing a blade is time consuming. I've made, V1.6, so I've made 6 major changes throughout these blades, and I'm getting very happy. So where I'm actually at right now is, let me throw my knife back together. Where I'm at right now is fine-tuning the actual tolerance fit of all of the parts, specifically of the blade into the handles, to the handle. Might as well show you guys. I'm just going to keep talking. Got my blade in, putting my pivot in. Pivot's really cool too, actually. So how do you orient a pivot so that it doesn't rotate and the logo is always up and down? Really shoddy camera work here, but right there. Focus. Right there. It's right there, people. Come on, camera. There we go. So if you notice, there's a little ceramic ball bearing drilled hole and pressed into the side of the button the pivot, that will match with a little groove cut into the top of the hole in the handle. And I actually really like it. It's simple, it's clean, it looks cool, feels cool, goes right in, doesn't rotate, feels awesome. All right, now I can put my pivot fully in. Not too tight, not too loose. Doesn't matter for right now. Okay, next I put in my spring, boop, and my button. Remember, we got to open the blade a little bit past normal, get the button all the way down, and then close the blade however much, and then I can put a stop pin in place. I actually think I need this stop pin for this blade. Now, just like how we make our Rask and our Norseman, our stop pins are stepped, and we make them in 1/1000 increments from, say, 1/8 inch nominal for the Rask down to 0.110 or something. I don't know exactly what our limits are. That allows us to tweak and fine tune the detent and the lockup separately for our knives. And I want it to have the exact same theory here. So this guy threads in like that to a dead stop. So this is our locking pin and this is our detent pin. So as the blade closes, the kind of part of the choil here is contacting that detent pin and stopping the blade from going too far down, and also engaging the button so that the detent of your button is good. And because I'm swapping parts around so much, I'm pretty sure this is the wrong small pin, the detent pin for this blade. It is. So right now my focus is on fine-tuning the position of the blade when it's closed, the position of the blade when it's open, the detent feature, the amount that it kind of pops, the way it feels, the way it pops out. Our knives are extremely particular with how they pop out, and we want that crisp, positive, bit of resistance force until it just pops and then it opens up. And that is absolutely paramount critical for our work. And then same for the lockup. Lockup on this, it's a button lock. I've never made a button lock before. I mean, the first Norseman was a button lock, but the first one, and it sucked and I didn't finish it. Button locks are different. So I'm fine-tuning how much the blade opens with not only the stop pin, but the actual machined groove right there where the stop pin rests. So that contacts that big stop pin right there. And we can do bigger or smaller stop pins depending, but I can also machine that feature to get the blade to sit perfectly perfect. And then not only that, but you want the button to come up into the tapered section of the blade to lock up just the right amount. My very technical measurement is to take a piece of paper from our notebook. I'm not going to rip it out because I value my notebook. Have the button stick up just enough that a piece of paper slips under the back edge of that button. And that is kind of my litmus test for proper button stick up. And that's, a piece of paper is like 4/1000ths of an inch. 2 pieces of paper, 8/1000ths shouldn't fit. So this one's actually really good. So that is the right stop pin, the right big pin for this knife. And then when you push the button, the locking feature goes away and the button is flush, and now the blade can close. And then as you close it, it should pop up, boom, right there. Doesn't pop up as much because now we're in the detent position. Detent, lockup. So what's really driving me crazy right now is that because I'm so smart and I designed this knife creatively, I'm over constraining the crap out of it. And that's usually a bad thing, but I'm really enjoying the challenge. So there's a lot of things going together into this knife to make it do what I want it to do. For one, I want the blade, I designed it so that the spine of the blade is flush with the spine of the handles. This blade is under and it looks stupid. I do not want it to be under. That's like 30 thousandths of an inch or way more under, and that is gross. Ew. Barf. I'd rather have it be, you know, up is also gross, down is gross. Flush is amazing, but anybody who's made assembled components and had them, like, try to make all the parts separately and put them together and have it be dead flush, like under 1/1000th of an inch, is, especially in this kind of orientation, it's really hard, like really, really hard. The steel distorts in heat treat, features move in heat treat. I could talk about that for an hour, and maybe I will at some point, but not right now. Anyway, so I'm trying to keep it flush when it's closed. And at the same time, in the same position, I'm trying to keep the detent features perfect, like absolutely perfect. Not only that, can you see that circular cutout? That's a pocket depth. This one's probably like 5 or 6 thousandths of an inch deep. Not enough. Part of that, well, that whole thing is my detent. The depth of it is incredibly important, and the position of it is incredibly important. So just to make the knife close and detent properly, let me see if I can list out everything I'm trying to do at once. I'm trying to have a flush spine with the handles. I'm trying to seat the blade against a nominal size stop pin. We do make bigger and smaller ones, but you know, go for nominal. So I'm trying for that. I'm trying to get the button to sit at the right depth in that handle, or in the blade, so the pocket has to be exactly the right depth, and the position of that pocket has to be in exactly the right place. Otherwise, you'll have play. The blade will kind of rock back and forth as you play with it, as you try to wiggle it. And this one does actually have a little bit of play. Yeah, like quite a lot of play actually. Theoretically, we want nothing. We want no play. I just want a positive, you preload it, and it just pops up. This knife, mine, AP01, flips okay. I know we can do a lot better. And when we were making the first 10, some of them were too aggressive and you literally couldn't flip them because the depth of that tiny little pocket in the blade was too deep, or the actual shape of the button, which is this complex, well, fairly simple but very tight tolerance radius, was wrong. So we fine-tuned the button, standardized the button. Okay, make all the buttons the same. Mess with everything else to make it work. So all those things have to come together perfectly to get the knife to flip the way I want. And I'm not there yet. I know we can do it. So to do all of that, what I've learned, I'm going to show you guys something. I'm going to bring you over to the surface plate and I'm going to show you something crazy. Take two blades, gauge pin. I've already barrel lapped the holes so that they're quite tight tolerance. Yeah, maybe I could just do this right here. So I'm stacking up two blades. These two blades were machined one after the other. They were heat treated together. They were lapped together. They were the same tolerance, the same size. Everything is the same. Except I'm doing a pretty good job of holding the two flat on the bottom. And look at the jimping and the flipper height. The tab is, I'm going to call that wildly different. Like, what the heck? So I've had this theory for months now, many months, possibly years, but the past few months has been a heavy theory, is that blades are moving during heat treat. We do our own heat treat, we're very precise, we're very consistent, and there are definitely research papers out there that prove that steels like A2 and stuff, you know, have a point whatever percent growth. I'm not talking about that. I'm talking about distortion. I'm talking about how between these two identical blades, and we soft mill these features, so it's heat treated kind of just like this. This section here is moving out. It's moving away, but only on one of the blades. It's frustrating. So all the blades that I just made, the 8 that I made the other night, do not have this slot. They have the pivot hole, but they don't have this slot at all. So I'm going to commit to hard milling that entire slot and finish hard milling it, and that lets me hard mill the detent stop pin position, the lockup stop pin position, and the depth of the button pocket, the whole slot, and the lockup feature in the blade, hard milled. It should be great, but it's going to be hard to do. Hard milling by itself is not the most challenging thing in the world, but maintaining tool life and accurate tolerance makes it a lot harder, especially over multiple parts. And I want to make hundreds of these, thousands of these, so I got to establish that process. To do that, I have my string of tools here, a lot of Lakeshore, a lot of DeBoer tool from Canada, Zadaro stuff also from Canada that I use. I'm going to start looking in, I have already started looking into hard milling end mills that are actually specifically designed for machining hardened steel, different grind geometry, different coatings. Union tool out of Japan is the one that really stands out. My buddy Adam, the machinist, put me onto them. So I'm probably going to be buying a bunch of Union stuff. They're not cheap, but they're not stupid expensive either. If I'm paying, you know, $10 to $30 for a DeBoer tool, a Union tool is going to be 18 to 90, depending on which one I'm getting for hard milling. So it is what it is. Anyway, that was a really good rant. Guys, I've been meaning to do that for a long time now. I hope you enjoyed it. I'm not saying this video's over, but I'm just saying, whew, that was good. I have so much to talk about. I have so much to show you guys. I haven't wanted to film. I just haven't wanted to. I've just wanted to work. But I can't tell you how many times I'm doing something and I think of what I would tell you while I'm doing it. But I don't want to go grab the camera. And I don't want to distract myself, and I don't want to disrupt. But I have so much to show you guys. Like, the shop is really something to behold. You know, I'm really proud of it. We got our Willem in there it's going to be making Fjell parts. We got a CMM optical comparator. I love that thing. The UMOX are still back there if anybody wants to buy some 30,000 RPM, amazing HSK spindles, two you know, VF2 size CNC machines. The price is right. I need them gone. I'll post more info later. And anyway, the current Speedio Aroa cell has been fantastic. We run those things every single day, except right now because it's broken. But the Speedio is great. So, okay. I thought this was kind of funny. On our website, we show the 8 Fjells that we've made so far. There's a 9th one, we just didn't post it. It's the one we have here. So that one's mine, that's Eric's, and then 6 of these that we sold at Blade Show 2024. This guy right here is what Thor pattern Damasteel is supposed to look like. And not supposed to, but typically looks like. Versus mine, which has the wavy pattern. These were made from the same bar, literally from the same bar. Isn't that crazy? Just a different piece. I'll show you guys since I'm talking about it. It's over here. Damascus. Yeah, I got this little scrap. Normally we buy kind of 2-inch wide pieces. This is closer to a 4-inch wide piece. And it's kind of, if the blade is made here, it looks like that. If the blade is made here, edge out, which, you know, the piece is so wide. I was like, oh look, I can make so many. I think I got 3, you know, in one piece. So I ended up with 2 of the stripy patterns and 1 of the normal middle solid pattern. So I thought that was interesting. Fun sneak peek. I'm going to give you a little insider scoop on Damasteel. We're buying more, and we just had a tool delivered today, upcoming video shortly-ish, that will make Damasteel, let's just say it's going to remove a big hurdle that I've had for Damasteel for a long time. This tool is, I hope, going to be freaking awesome, and you guys are going to like it, and we're going to like it, and we're going to get a lot of use out of it. And it's going to unlock Damasteel, at least one part of making the Damasteel process. So that's going to be epic. The other funny thing I wanted to mention looking at all these pictures is, see that weird thing on the pivot? Everyone has them. So what that is, Eric mirror polished these pivots. Mine's kind of dirty and maybe a little scratched up. Yeah, definitely a little dirty and scratched up. Anyway, they're mirror polished. They're really cool. That is the camera. The camera that photographed these. You know, there's the camera. I think it's the Canon M80. That's the tripod. So for future ones, the guys already know to, like, they're gonna do something different. They're gonna angle it or something like that to make it pop good. But when you have a brushed pivot or a ground pivot and a super polished button, it's just gonna reflect everything weirdly. Kind of neat. All right, my friends, it is Longines o'clock. It is almost 1 a.m. And I think I'm done. I didn't get to make anything tonight, except for this video. But I got some good thinking done. The current had to get fixed. Yeah, so next few days, I am fine-tuning my hard milling of all these little critical features, trying to get that blade to position exactly where I want it to be. I'm confident I can get it done. I'm less confident on tool life, but I think with union tools or something very specific, I think I will get what I want. And the price will be absolutely worth it. So that's good. That's really good. Oh, I want to say, if you are interested in our Fjell knife and you want to sign up for our interest list, by the time this video goes up, it should be on our website. If you go grimsmoknives.com, there's a Fjell page. It should say, maybe on the Fjell page or on the sign up page, there'll be a link to sign up to the Fjell. And then you'll be notified, you'll get picked, yada, yada, yada. We're probably gonna do buyer's choice for these, and it's gonna be sick. So, thank you so much for watching, and I got more videos for you. All right, later.